Good afternoon, everyone. Today we are going to continue with our class on chapter 3. Let's take a look at where we stopped the other day. I believe we stopped at activity 3.3. I've already assigned some of you. Let me take a look. I think I have the data. Kevin, Fatin, Abu, and Mafira for the subsequent activities. So let's just go through first. Let's see. All right. I think last class, right, we have gone through activity 3.2. Let's us recap what we have studied last class. So we have we have no about understand about the concept of specific energy. Um, Okay, we have studied about concept of specific energy, which is measured from the channel's bottom. Therefore, specific energy is the depth plus the heat of velocity. And then we have, this is the specific energy curve. All right. Um, well, it doesn't matter how you draw or where you put your specific energy and depth of flow, on which axis do you put it. However, it is easier lah, right, if you put the depth of flow on the y-axis, because it represents the depth of flow itself lah, right. I need to admit those who just came in. It's good if you try to get in before our class, so that we can have smoother session. Okay, now so this is the E to Y curve lah. Last class I have already shown the using the Excel file how you get this. Basically, for each depth of flow, you are going to get a specific energy, because you calculated your specific energy based on this formula here. This formula applies to all section. It could be compound section, all right, trapezoidal, and it also include rectangular. However, for rectangular section, you can simplify this. All right, just a second. I need to admit those who want to join. Okay. Um, okay, still okay. All right. Now, um, okay, I miss. Okay. Um, so this you really have to understand this EY curve, because we are going to test you in your Tesla, all right, on the understanding of this EY curve. All right. EY means you have on one axis you have E, and the other axis you have Y. Right. So this is the curve lah. Apart from minimum specific energy, which you only have one depth of flow, which is the critical depth of flow, the other values of specific energy would give you two or one set, which consists of two depth of flow, one in supercritical state and another depth of flow in subcritical. This is known as the alternate depths. All right. Um, okay. You also have to understand what is alternate depths is about. Or in other terms, you may use conjugate or sequent depths. For conjugate and sequent depths, those are typically used in when it involves energy loss. All right, for example, in hydraulic jump, but it's similar, right? It has a similar meaning, where for one specific energy, you are going to get two depths of flow, which is in a different state of flow. Now for conjugate, normally you'll use the QY curve. All right. Um. Okay. Wait, nah. Let's see who want to join. Okay. All right. Um. Okay. Now. Mm, because I keep admitting student, right? I forgot where I been, going through. Okay, I think I've shown this also. For if you are using specific energy equation as well, you can also show that critical flow occurs when Q is maximum. All right, it's either minimum E, minimum specific energy, or maximum Q. All right. Let's see. All right, this is conjugate depth. Huh? It has the same meaning. All right, except that this involves, it has to do, it also consider energy loss lah, basically, right? Now we have gone through this. Okay. Um, all right then. I believe, I think Kevin will start to solve activity 3.3. So let's just go through this. I probably have gone through this before. So let's look at this. You have a flow where the discharge over unit width is given 1.23. The channels is 1.6 meter wide, is rectangular. The depth of flow is 0.65. All right. It asks you to calculate the specific energy. After that, you need to find the alternate depths of the flow. All right. So first, you need to calculate this specific energy. So using this specific energy, you can get the depths of flow lah, the alternate depths of flow. Right. Then you have to justify lah what state of flow. Definitely, normally the lower depth of flow would be in supercritical state, and the higher depth of flow would be in subcritical. Right, of course, in this case, you need to show the Fred number lah to justify it. And then I think we have gone through this. For this one, right, so I'm not sure about my answer, but I would like Kevin to help me in this case, all right? So I'll pass the screen to Kevin, please. Kevin, you want to...
Yes, doctor. So I will present activity 3.3. From the question given, A is equal to 5.2 and Q is equal to 13, and the width of the channel is 3 meter. So first, we need to find YC. We use this equation, YC equal to Q squared over G power 1 per G, and substitute the value, and we get 2.583 meter. And then to find y, we use this equation, E equal to y plus q squared over 2gy squared.
Kevin, can I ask you one question?
Yes.
Okay. You just go ahead. Could you show me your calculation? I wanted to ask you based on your work. Okay, here's the thing. You are using this E equals to Y, the specific energy expression, where you have E equals to Y plus Q squared over 2GY squared. You have this, you are considering discharge over unit width. This expression, can I use this to calculate for specific energy for flow in trapezoidal channel? Could I? Kevin?
Can.
Um, okay, help you answer then, Kevin. All right. You cannot because normally the discharge over unit width, right? You are using it for rectangular channel. For if for trapezoidal, triangular, or any other compound section, right? Apart from rectangular channel, you are going to use the discharge, uppercase Q, Q squared over 2GA squared. Agree, Kevin?
Agreed.
Okay, thank you. Please continue, Kevin. I'll stop.
And then we substitute the value and get 5.2 equal to y plus 13 squared over 2 times 9.81 times y squared. And then the whole equation we times y squared, and we get the new equation y cubed minus 5.2 y squared plus 8.614 equal to 0. We're using calculator to solve this equation. We get y equal to 4.831 meters and y equal to 1.533 meters.
All right, thank you, Kevin. May I ask you? Okay, here's the thing. Um, if we take a look at the last third line, okay, baris yang ketiga terakhir, iaitu 5.2 darab y kuasa 2 sama dengan y darab y kuasa 2. Nah, kena hati-hati ya. You have to be careful. Normally kita akan darab sebelah kiri dan sebelah kanan dengan y squared. Jadi kalau it is best lah kalau kita bracketkan uh, expression sebelah kanan tu expression sebelah kanan iaitu y plus 8.614 over y squared. We bracket it and we times y squared. You just have to be careful. But in this case, what Kevin did is, he just show y times y squared. I'm just worried that there will be another expression. So you just have to be careful lah, basically. But this is okay. What I mean, if you are not just times y squared, let's say you have to times y squared plus something, right? So you have to be careful lah, right? So this is correct, okay, Kevin? So the way Kevin did it is, okay, he I think you insert this expression in your calculator. Am I right, Kevin?
Yes,
Okay. Now, could you describe how many times you have to how do you solve this using your calculator? Just just try to explain it in simple way. Is it okay, Kevin?
okay.
All right.
I will press more and then 5 and then choose
Why do you need to press mode 5?
to solve the equation.
Sorry?
To solve the equation.
Okay, right, okay.
And then we choose number 4 because number 4 can solve the cube.
Cubic. Okay.
And then we insert the value
All right.
A, B, C. A is 1, B is negative 5.2, C is 0, D is 8.614.
All right.
And then we get the answer.
Okay. Is I think this is in the YouTube video that I've shown, is it?
Yes,
Okay, so you guys, you can take a look at the YouTube video that I've shared in the group. Maybe if you couldn't find it, maybe one of our friends in our class, right, could actually, share it again if you can find it. The YouTube video, you can actually, it's very simple. You can actually get, both answers. Am I right, Kevin?
yes,
You can get both answer, right? Okay. Thank you very much, Kevin.
thank you.
All right. I appreciate you guys really have good or neat writing, for us, right, if you want to do marking, right, or grading of your paper, we are happy if we get, you know papers with neat writing. All right, it makes our life easier, like, basically, to check your answer. All right. Okay. Thank you. Any question for Kevin? Ada soalan tak nak tanya Kevin? Bahagian kita ada, let's see. So this is what Kevin did, eh? Okay, so both of us got the same answer lah, right? So basically kita kena selesaikan persamaan ni. Jadi memang Kevin tulis dalam, dia rewrite this expression lah, right? For him to solve it easier in calculator. So you're going to get y1 and y3 lah. Okay, now this is how I show it. For me, right, is sometimes I like to visualize my answer, so I'll draw this out. You need to understand this EY curve, because you'll be tested on this. So try to understand this. For example, if you look at this okay, I purposely draw the E equals to Y because I know that my EY curve would not intercept E equals to Y line. It's just going asymptote to E to equals to Y line, and also towards the E axis lah, or your X axis, all right? Of course, this curve has a minimum E, which is E mean, corresponding to our depth of critical flow, YC. Now, for any E, okay, you are going to get a set of Y, the alternate depths. This is what Kevin has done lah. All right. Now, of course, this YC, right, will falls between these two values, all right? Because this question doesn't ask for YC, then you don't need to find or give YC. But in this case, I have also shown lah YC to be this, okay? So this is, if I want to check, one depth would be less than 2.583, and another depth, which is a subcritical, would be greater than 2.583, okay, which are these values, all right? Okay, let's go ahead with our
Doctor,
today. Yes.
why the E minimum equal to 1.5 YC?
Okay, where is it? Is it here?
Yes.
Oh, here. All right. Okay, here. Okay. Wait. Do I have the slide here? Is it afterwards? I think I remember the slide is afterwards. It's here. Okay. Okay. Let's. Who is asking? May I know? Because I couldn't see the.
Ding Xiang.
Okay, all right. Okay. Now, essentially, I'm going to explain this. Okay, this E equals to 1.5 YC only applies to rectangular channel. So I'm going to show the simplification later. Now, for all other section, including rectangular channel, okay, you have this expression, right? E equals to Y plus, Q squared over 2G, sorry, A Y 2G A squared. Okay. Now, this applies for all section, including rectangular channel. So if you want to find E mean, all right? If you want to find E mean, okay, oops, sorry, this would be YC and this will be AC. That means because your flow area is actually a function of YC as well. A flow area is a function of depth of flow. So if this is in critical state, all right, this will be E mean. Clear about that? You have the expression Everyone clear? Semua setuju Maknanya kalau nak cari E mean, Y kita kalau kita tengok di sini pun ataupun sebelum ni kita pun dah pernah tunjukkan dalam keadaan critical ukur dalam critical specific ataupun tenaga tentu adalah minimum, iaitu di sini. So ini ialah YC lah Ini pun AC sebab A nak kira A pun bergantung pada Y. So kalau Y sama dengan YC, A kita AC lah. So kita akan dapat E minimum. Tetapi untuk segi 4, kita sebenarnya boleh tunjukkan E minimum sama dengan 1.5 YC. Okay, let's take a look at that. Now, calculation of critical depth. Okay, now critical depth from trial and error. So we actually have this expression earlier. Okay, just a second. Okay, remember this expression here where we set, we have this specific energy equation. We differentiate the specific energy with respect of y. So we have that. So setting dE over dy equals to 0 will give us q squared over Ga, q squared t over Ga to the cubic power equals to 1. Okay. So therefore, this is the expression. Okay. Okay. Then, okay. Now, this is when we set, you know, when we set the condition to be critical flow. So we have this q squared t over Ga cubic power equals to 1. Now, I'm rearranging this, if you look at this, right, okay, if you remember when we want to find depth of uniform flow, we would have section factor where we put in Manning equation, right? We put AR to the power of 2/3 on one side and we have Qn over S naught to the power of half on another side, because we said section factor is a function of depth of flow. So we want to find depth of flow, we arrange our expression. In this case as well, all right, this is written as a function of critical depth of flow. If you look at here, q squared over G, all right, when we, in this case, right, we set Q is constant, all right, so we have Q squared over G. This is in terms of depth of flow, or as a function of depth of flow. So this is also similar to our section factor because A and T, all right, depends on depth of flow. So this is how we are going to find our YC. Okay, so it's similar, except that in this case, we are not using Manning or Chasey, because for Manning and Chasey, we are using them to find depth of uniform flow. To find critical or depth of critical flow, we are using this expression here. Okay, so we are just rewriting, all right, this expression in terms of as a function of depth of flow equals to Q squared over G. Clear so far? Semua jelas
Okay, Doctor.
Okay sebab dalam case ni, kalau nak cari ukur dalam critical, kita dah tak guna Manning atau Chasey tau. Sebab formula Manning dan Chasey kita gunakan untuk dapatkan ukur dalam aliran seragam. Bermula bab 3 dan bab 4, kita sebenarnya belajar aliran tak seragam. Jadi kita tak akan gunakan Manning atau Chasey. Jadi kena hati-hati kalau tengok soalannya. Kalau soalannya cakap ataupun adalah pemboleh ubah Manning dan sebagainya, ataupun Chasey, kita tahu soalan tu sebenarnya adalah soalan berkaitan aliran seragam. Tapi kalau sentuh pasal critical flow ni, ini ialah aliran tak seragam dah lah ni. Okay, sebab tu kita tak guna formula Chasey atau Manning lah dalam kes bab 3 dan juga bab 4. Jadi formula yang kita akan gunakan ialah contohnya kalau keadaan ni dia minta kita, sebelum ni kita ada formula tenaga tentu. Tapi daripada formula tenaga tentu, kita dah tunjukkan bila aliran adalah critical, kita dapat formula ni. Sebenarnya formula ni juga boleh ditunjukkan kata fruit number sama dengan 1 ini pun fruit number sama juga 1 Sekejap ada yang nak masuk session ni. Okay, Faizul. Okay, jadi okay, formula ni. Jadi sebenarnya konsep dia sama. Kita nak dapatkan ukur dalam aliran kritikal. Jadi kita susunlah sebelah kiri ni. Okey, rumus dia ialah kalau tengok parameter A dengan T ni sebenarnya fungsi dalam ukur dalam aliran. Q ni biasanya constant lah Q square over G ni sebelah kanan. Jadi sebenarnya kita boleh selesaikan ukur dalam aliran kritikal. Okay. Right. So now, just now, okay, our friend asked, why can we get E equals to 1.5 YC? Okay, we are going to show it here. Untuk keratan segi empat, sebenarnya formula-formula ni kita boleh permudahkan. Okay. Jadi kita tak perlulah nak cari AT kan. Dan kita boleh gunakan ukur dalam, kadar alih per unit lebar. Okay, iaitu lower case Q lah. Okay. Untuk keratan segi empat if you look at this rectangular channel or rectangular section, our top width is actually equal to the width of our channel lah. Alright. So our flow area is BY. Okay, substitute A equals to BY, T equals to B, you have this. Okay. Now, I think I've shown this earlier, last class, I remember. So B cubic power divided by B, you are going to have B squared, which I move to the right. Okay, therefore you have this, right? So therefore I only have Y to the cubic power left on the left side. So Q squared over B squared, this is discharge over unit width squared. Okay, so we are going to have Q squared over G. So I have cubic power here, I move it to the other side, or I cancel the cubic power here, so this become cubic root. Alright, so you have cubic root Q squared over 2G. Now remember this formula only applies for rectangular because we set A and T. Alright, we substitute T equals to B and A equals to BY. Okay, remember? Alright. Now, we also know, alright, critical depth occurs when Q is maximum. Remember the derivation earlier, right? Okay, so Q squared equals to square root 2G. This is actually coming from our formula, the specific energy, alright, which is this one. For rectangular channel, we have okay, I hope you still remember this for rectangular channel. I already show you that means you have QA, you can divided by B squared, alright? Both the numerator and denominator divided by B squared, so you are going to get this, alright? So you rearrange this expression, rearrange this, you'll get this, alright? If you look at it, it's similar, right? So rearranging this and then square both sides. When you square both sides, you are going to have this. Now, differentiate Q with respect to Y. So basically, this expression here is actually Q squared. If I'm going to rewrite this side, Q squared equals to 2G E Y squared minus 2G Y cubic power. Right? This is the same, right? Basically the same equation, right? So I differentiate Q with respect of Y. I have 2Q dQ dy, right? This one. Okay. Then I have 2G. Alright. I actually have actually have 4GEY. This is 4GEY. Okay. And this would be negative 6GY squared. Negative 6GY squared. I actually factor 2GY. So I have 2E minus 3Y. Okay, I hope you are clear about this. So, when I set Q maximum, right? So I have dQ over dy equals to 0. All right. you see, this one, if dq over dy equals to 0, if I bring this term to the left side, 0 divided by something, you will get 0. So you are left for only for this term, 2e minus 3y equals to 0. Therefore, your yc, you can show that E mean is actually equal to 1.5 YC or 3 over 2 YC lah. Alright. This only applies for rectangular channel because you are using this expression here. Alright, where you are using discharge over unit width, where you said, your assumption would be, Q divided by Q over B. Sorry, this is B. And then this one, all right, you have simplified it from this. Y equals to, all right, basically A over B lah. All right. So if Y squared, that means you are going to get this lah, basically. All right. You divided by B lah, the same thing. All right. Okay. Clear Yang ni jelas? Macam mana dapat yang ini?
Jelas.
Jelas Okay. Ini terpakai untuk keratan segi empat. Kalau bukan segi empat, of course kita kena guna balik lah yang persamaan tenaga tentu, iaitu yang ini. Ini maknanya kalau nak cari E mean, alright, ini ialah YC, ini ialah AC. Clear sebenarnya kalau you tanya saya, boleh tak keratan segi empat pun guna formula ni? Boleh. The answer would be the same. Okay, it depends, alright. You want to use which one? Of course, I would choose this because it's much simpler. Okay, I don't need to find all this already. Okay, I only need YC. So I hope you are clear. Alright. Now, critical slope. I think the other day I asked, Fatin, Abu and Mafira to try out the question first because I haven't explained this yet. But I think they are good, all right? Okay, thank you. You're good, All right. So here's the... Yes, saya.
If we want to use the YC over 2, right? So we need to show, is it E mean equals to how we get the 3 over 2?
No, you don't have to. Unless, all right, unless the question asks you to prove. Okay, from here, all right, to prove it, that means the question would be prove that for rectangular section, all right, E mean is also equals to this, all right. The question probably give you this expression already, all right. Prove that this for rectangular section, this becomes this. So you have to go through this lah. Okay, clear?
Clear.
Maknanya kalau soalan tu minta buktikan persamaan ni akan jadi persamaan ni bila keratan segi empat digunakan. Jadi kita kena tunjukkanlah step ni. Kalau tidak, you boleh gunakan terus ini. Most probably kan dalam formula pun akan diberi. So jangan risaulah. Okay. Now, for critical slope, right? Of course, slope, for critical slope, the longitudinal slope or the slope of the channel's bed is SC. If it's mild slope, right? Of course, your SC would be smaller than your S would be smaller than SC lah. Okay, if S is large or your S naught is large, that means it's very steep. If your S is small number, all right, it is very mild. It's mild lah. Okay, so therefore, if S is less than SC, is mild slope. If it's greater than SC, it is steep slope. All right. Now, how are you going to get the formula to find SC? You see, this is the expression for critical flow. Okay, so I'm going to rewrite this, all right, and make Q as the subject of my formula. So I have this. It's actually just rewriting from this formula here, okay? Now, if you look at this is our Manning. formula, if you still remember. So we have Q equals to this. So what I did is I actually have this, I solve this expression because this is equal to this. So square root QA cubic power T equals to 1 over N AR to the power of 2/3. So I'm going to get this. Let's let's show this. Because I'm going to show this so that you can see the blank paper, right? Are you able to see this?
Yeah.
Yes.
Yes, eh? Okay. Now, just now I said I have Q for critical flow, right? Okay. I have Q equals to, all right, G A cubic, all right, power over TC. Now, from uniform flow, I also have Q equals to 1 over N A R to the power of 2/3 S naught to the power of half. Okay. Now, let's say if it's in critical condition and is under uniform flow as well in critical condition, what I could do is this would change to critical state lah. All right, so I have that. Okay. Now what I did here, I equate this. All right, since both are Q, all right, I equate this. I have because why I need this formula here, because I want to find critical slope. Okay, so that's why I'm using this formula. For this formula, if you look at here, there's no slope. It's not affected by the slope of the channel. Okay, so here's the thing. I wanted to make this as C as the subject of the formula, so I'm going to rearrange this. So what I'll have here, I'm going to square both sides. All right, so this will give me, I'm going to switch. So this will give me 1 over N squared. All right, AC squared RC 4 over 3. Okay, so this will become SC. So this is G A over TC. Okay, so I'm going to rearrange this. So everything I'm going to move it on the other side. So I have this one, N squared. Let me set this G. Okay, I have A C cubic divided by, okay, here's the thing, I have A C squared. Okay, what else? I have R C 4 over 3 and I have T C. Now I could cancel this. Okay, so I have N squared G A C over TCRC 4 over 3. Okay, which is the same formula lah I'm using. So this is the formula that you are going to use to find the critical slope. Okay, let's go back. So you have this formula ready. Okay, now let's look at this activity 3.4. Because I think I've assigned Fatin, Abu, and Mafira for activity 3.5. So here's the thing. This activity 3.4, all right, is actually is about rectangular channel. So when the question asks me to find critical depth, okay, I could use either the formula of Q squared over G equals to A cubic power over TC, or I could choose to use this equation here. Okay, so I have, that means I can consider this or I can use this formula. All right, so it doesn't matter. This one is G over A C cubic over TC. All right. So it doesn't matter which formula. You'll get the same answer. Of course, this one, you need to solve this first lah. Alright, okay. T is equal to B lah. It doesn't matter. So, but for me, this is simpler. I will just find this Q. Alright, this Q,
So we
which
only
is
can use both this formula for the
yes.
rectangular channel.
You can use both. Alright, you get the same answer. Don't worry. Exactly the same answer. Alright. Um, so kita boleh gunakan dua-dua persamaan. Persamaan ni boleh digunakan untuk semua keratan, tak kisahlah trapezoidal ke compound ke apa-apa saja. Tetapi formula ni hanya boleh guna untuk segi empat saja, keratan segi empat je. Kena hati-hatilah. So kalau tengok formula soalan ni dia cakap rectangular channel. So saya gunakan memudahkanlah, saya tak nak cari A dan sebagainya kan. Jadi saya guna teruslah formula ini. So I just find my discharge over unit width 25 divided by 4. Alright, so that's why this is the one. I can straight away find my discharge over unit width first, then I substitute in this equation. Sama juga. So boleh cuba nanti I think you have to try this. Kadang-kadang kita lebih suka cari ini dulu, jadi you know, find your style, okay, style of calculations which makes you feel more comfortable. Okay, kadang-kadang kalau you ganti macam ni mungkin you rasa macam takut silap kan. You cari dulu siap-siap kadar alih per unit lebar, cari dulu siap-siap baru gantikan dalam persamaan ni pun boleh. Jadi kena cuba. Kalau tak cuba you tak tahu style you nak jawab tu macam mana. Therefore critical depth is 1.85. So you have critical velocity. Okay, you can find critical velocity, it doesn't matter. You can find V equals to Q over A also. Boleh. Tak ada masalah. You can also use, when fruit equals to 1. Pun tak ada masalah. Mana-mana formula you akan jumpa juga. Sebenarnya you akan jumpa VC juga. Sebab kalau fruit equals to 1, sebab dia keratan segi 4 kan, you can actually have V over square root GY. Untuk segi 4. Kalau tidak, you kena guna D, the hydraulic depth, which is A over T. So this would be equal to 1. You can actually find, since you already have YC, right? You can find your VC lah. Maknanya VC sama dengan square root GYC. Itu je. Simple kan? So mana-mana you boleh guna, you akan dapat juga jawapan yang sama. So critical slope just now you use the earlier formula lah that we have derived kan. So the same thing. Let's go through lah. So I chose to use this lah. Alright. Since D is equal to A over T. Alright. So for rectangular channel, this is B over Y over B. Therefore, you equals to Y lah. Alright. So therefore, your VC is just this. Okay. Now, for critical slope, is N squared over GA. N squared GA over TR to the power of 4 over 3. Sometimes when I talk, I think about the next step. That's why. Alright. It's just too fast. Alright. So I'm going to go slow. For rectangular section, T is equal to B. So this one is BY. So you cancel B, you are going to have Y here only. Alright. So you substitute lah. Alright. You are going to get, still you need to find R. R is equal to A over P. You cannot set R equals to Y because, okay, I want to ask Mafira, since you are solving this equation, right? Mafira, this question.
Dah saya.
Okay, Mafira nak tanyalah, bila masa kita boleh set R sama dengan Y
Kalau dia white, very white, lepas tu kalau rectangular ke? Sebab kan Y atas tu, A tu boleh potong dengan bawah tu.
Okay, thank you Mafira. You still remember, that's good. Okay, because soalan ni tak cakap very wide kan. You also didn't show whether the Y over B is less than 0.01. So therefore, you you need to find A and P lah. All right, you cannot set. So this is not applicable for this question here. So if you look at here, you need to find A and P lah, basically. Therefore, you can find C. All right. Okay. Now, I need Fatin to help me find critical depth for this activity. Fatin, are you ready? I'm
Yes.
going to unshare this.
Okay, doctor.
Okay, Fatin, please.
Yes, doctor.
Fatin, are you there?
Yes.
Okay, great. Okay.
Sekejap
Okay, take your time.
Okay, I will present activity 3.5.
Alright.
In the question given that nilai B ialah 1.2 meter, Q sama dengan 0.8 meter cube per second, N sama dengan 0.02, side slope sama dengan 1 nisbah 1.5. Daripada tu kita dapat nilai Z sama dengan 1.5. Lepas tu saya buat satu-satu.
Tak apa, Mafira, it's good. This is actually help your understanding as well. Thank you, Mafira. Thank you, Fatin.
Okay, so saya mula guna specific energy punya equation. E sama dengan Y tambah Q kuasa 2 per 2GA square. Lepas tu saya differentiatekan dia, kita akan dapat equation DE per DY sama dengan 1 tolak Q kuasa 2 per
So,
GA.
nanti kalau ada soalan proof ni, you tak ada masalah dah lah kan? Okay, silakan.
GA cube DA DY. Lepas tu DA DY tu sama juga dengan nilai T. Jadinya dia sama juga dengan 1 tolak Q kuasa 2 per GA kuasa 3 T lah. Okay, untuk cari Y critical, E kena minimum. Kalau E minimum maksudnya DE DY sama dengan kosong. Lepas tu saya masukkan nilai DE DY tu sama dengan kosong dalam formula ni. Lepas tu saya susun, nanti saya dapat formula yang sama dengan ni lah. Q kuasa 2 per G sama dengan A kuasa 3 per T. Lepas tu dalam soalan dia bagi nilai Z dengan nilai B. Sebab ini trapezoidal punya channel, area dia sama dengan BY tambah ZY square. Lepas tu saya masukkan nilai, kita akan dapat nilai area sama dengan 1.2Y tambah 1.5Y square. Bagi nilai T, dia sama dengan B tambah 2ZY. Masukkan nilai, kita dapat 1.2 tambah 3Y. So daripada nilai A dengan nilai T ni kita masukkan dalam formula yang Q kuasa 2 per G sama dengan A kuasa 3 per T tu, kita akan dapat sama dengan 0.0736 sama dengan 1.2Y tambah 1.5 Y kuasa 2 kuasa 3 bahagi 1.2 tambah 3Y. Lepas tu saya guna kalkulator je, lepas tu saya dapat YC sama dengan 0.3222 meter.
Okay, terima kasih Fatin. Very clear. You have a lengthy of work here. Alright. It is good that you have gone through all the derivation. Okay, it's good. We are clear too now. Tadi just now I show solution for rectangular section. Now Fatin have shown solution for a trapezoidal section. If you look at the formula, right? In my case, since it's a rectangular section, I can use simplified formula, which is for example YC equals to cubic root of Q squared over G, and also if I need to find the specific energy, I can find E mean equals to 1.5 YC, but for all other section which also include rectangular section, you can use this formula that Fatin have shown here. All right, so I hope you are clear. To find critical depth of flow, you need to use this formula. But if the question asks you to find depth of uniform flow, you can use Manning or Chasey lah formula. Okay, you need to differentiate between chapter 2 and chapter 3 lah basically. Thank you, Fatin.
Okay, thank you.
Alright. Next one, I would like to have Abu solve for question B. Abu, please.
Doctor, I have a
Yes.
question.
Yes.
For activity 3.5, the ratio of side slope is 1:1.5, right?
Correct.
If like that, the 1 is horizontal and 1.5 is vertical, or
Okay, normally, right, if it doesn't state, we are going to have vertical to the ratio of horizontal. Because normally when we find slope, right, it's actually the vertical divided by our horizontal distance. Am I right?
yeah.
So we'll state the vertical and horizontal first. Unless, all right, unless it's specified, it give you, horizontal first, then vertical, then you are going to use it the other way around lah. Okay, Johnson?
Okay, so in this question, the vertical is 1 and the horizontal is 1.5 lah.
Correct.
All right, thank you.
Okay. Thank you, Johnson. What Farah have shown just now, Fatin have shown just now is correct. Okay. All right. Abu, please. The next question.
Okay, Assalamualaikum. Dengar?
Dengar?
Okay. Sekejap.
Sabar. Take your time.
Okay, nampak tak?
Nampak?
Okay, baik. Okay, yang first kali ni adalah formula bagi fraud. So, kita salin formula ni dulu. Then, kita nak cari VC ni. So, bila kita nak cari VC, kita buat...
Abu, saya nak tanya satu soalan. Bila Abu set VC over square root GD, itu formula fraud, sama dengan 1 tu maksudnya apa? Keadaan
maksudnya dalam keadaan kritikal.
Okay, thank you. Okay, maknanya Abu faham lah. Okay, silakan.
Okay, kita ubah persamaan dia, kita jadikan VC ni sebagai tajuk.
Alright.
And then D ni kita tak ada lagi. So, kita kena cari D dululah. Dan formula untuk D, dia tak boleh kita samakan dengan Y sebab dia bukan rectangular.
Betul.
So, kita kena kira balik lah dia punya area dengan dia punya T. So, ni dia punya persamaan. And then, kita ganti masuk nilai Y yang tadi yang kita dapat dekat soalan A tu. After that, kita dapat jawapan ni. Dan kita masukkan jawapan ni dalam persamaan tadi. Okay, after that kita dapat jawapan VC. Itu critical velocity.
Alright, terima kasih. Sekejap saya cuma nak fahamkan. Oh, D sama dengan 0.2503 meter. Okay.
Yeah.
Sebab banyak sangat sama-sama. Dia kena differentiate Sebab saya nampak square root 9.81 darab 0.2503 sama dengan yang sebelah kanan.
Oh, okay.
Nanti mungkin
kena buat line lah.
Gariskan.
Okay.
Abu orang Pantai Timur
Tidak. Kedah Utara.
Kedah. Oh, okay. Alright. Okay, samalah tempat dengan saya Saya pun Kedah. Alright. Sebab you're quite pekat Alright. Okay, thank you Abu.
Okay.
Alright, thank you Yang lain ada soalan pada Abu tak? Do you have any question for Abu? Looks like none
No.
Yes, Taba.
No.
No, okay. Then I'm going to call
Doctor, I have a question.
Yes, Johnson.
For V, right? If I use a Q equals to AV, can or not? Cannot. But the answer will get some different number.
Can I ask you? Wait. When you said Q equals to AV,
Yeah.
you want to find V?
Yeah. Yes.
Your A is AC, Am I right?
Yes.
You should get the same answer. You should get the same answer. You should get the same answer.
Okay. All right. Thank you.
I'm going to help you check. You can show me your calculation later. Q V. You should get the same answer. All right, Johnson. Now, can I have Mafira, please? The
Ya,
final
saya.
question, right?
Hai, boleh nampak kan?
Nampak dah.
Okey, soalan dia Fatin dah bacakan tadi. Dia
Alright.
punya B 1.2, Z 1.5, lepas tu N dia 0.02, Y Fatin dapat 0.322. Okey, formula untuk AC adalah N kuasa 2 GAC per dengan TC RC 4/3. Okey, kita dapat formula. Soalan dia nak minta trapezoidal kan. So kita listkanlah formula untuk trapezoidal ni. Lepas tu kita substitute lah A dengan formula A. Lepas tu P dengan, okay, A dengan formula A. Lepas tu T kan dengan formula T. And then R, A over P. A over P. Then kita substitutekan semua value ke dalam formula ni. Kita dapatlah 0.006985. Faham tak?
Yang lain faham tak? Apa ni, Mafira tengah tanya kita semua ni. Saya faham lah. Kawan-kawan lain? Okay, clear
Faham.
Faham. Okay, thanks Fatima for respond. Here's the thing you Mafira thank you Mafira. It's clear. Nice writing. Okay. It's clear. Here's the thing, you have to try it on your own. Sebab if you look at the formula, right, it's quite lengthy, right? Unless you try it on your own, I don't know, probably sometimes, even when you're trying to key in calculator, right, you'll make mistake. So you have to try it on your own, make sure you have the proper brackets on and things like that. Now, Jordan, just now you asked me question, right, regarding if you can use this B equals to Q over A, right? Jordan?
Yeah.
Actually, I just calculated while Mafira was presenting. I can actually find this exactly the same answer.
Maybe I calculated wrong.
Here I'm showing it to you, which is actually, I think maybe it's more simpler, like you said here. It's the same, right?
Yeah.
Try to get this. AC should be 0.5 because this is constant, right, Q?
Yes.
AC should be 0.5424. All right, you're going to get this. Okay? Okay,
Okay.
All right. I think you are using, if you are using this mass conservation equation, it looks simpler, all right? But anyhow, you can use various equations lah, all right, which is related lah. Okay. Now let's go back. Okay, thank you, Kevin, Fatin, Abu, and Mafira. Let's look at our let's continue with our lesson. Okay, what am I doing? Okay, your entire screen share. Okay. Oops. Okay. We have activity 3.6. I'm just going to go through very fast because this is actually similar to activity 3.4. It is it is on rectangular section. Okay, it has which is 3 meter wide. discharge is provided, Manning coefficient is provided. So you need to find critical depth, velocity, and slope. Okay, you can try this on your own because this is similar to activity 3.4 or 3.3. Okay, all right. So you have that. Okay, this is just because students keep asking for more activities, right? So I'm just giving more activities so you can try on lah. Right. Now activity 3.7. This question, if you look at this, and infinitely wide. So this is very wide. If it's infinitely wide, your hydraulic radius R, okay, you can approximate R equals to Y. If you look at here, okay, R equals to Y. Okay, this infinitely means tak terhingga, sangat lebar, tak terhingga. Okay. So the question asked us to find critical depth. Okay, you could actually use the simplification YC equals to Q squared. Sorry, G over Q squared. This is correct. Over 1/3. Okay, you have that. You can find critical depth, then Freud number. Okay, you can find Freud number, type of flow. All right. Using when depth of flow is 6 meter. The question asks you to find Freud number when depth is equal to 6. Jordan, can I ask you one question, Jordan?
Yes.
If the question asks find Freud number for critical depth, what would be your answer?
One again, the question.
If the question asks find Freud number for item 1, how are you going to find it? Okay, no, I actually just purposely asked.
I will use FR equals to Q over square root GY cube.
Square root GY cube. Okay. All right, correct. And the expected answer will be Freud number equals to 1. Am I right? Because it's critical depth.
Yeah.
Okay, great. Actually, I just wanted to test you on that, which is clear. You are expected to get 1 lah, all right, since it's critical flow. Okay, so find critical slope of channel if Manning coefficient is 0.004. So you are using that expression lah that we have already come up with earlier. Okay, now you can try this question. Based on river characteristic given in A, okay, find the possible depth of flow Y2 for the same specific energy. So therefore, okay, you need to find specific energy first. Okay, then you need to find the Y. You have Y1 and Y2 lah basically. And then find Freud number for this Y. Now, this specific energy that you need to find is for this case here. All right, because critical depth, there's only one depth, at E mean, okay? So for this question, of course, you need to find for 6 meter lah. All right, you are going to check because for this question, right? It has already asked you to check what type of flow. So you know that if this is subcritical flow, you are going to expect this to be supercritical. Actually, there's hint lah in the question if you understand. That's why sometimes when we answer question, right, we'll just look at it, read through it properly. Sometimes it'll provide hint to you. All right. Try this out. It's simple lah, basically. This is how you do it lah. Okay. Straight away. This is the simplification for rectangular section. Okay, so you have that. Now I need to share this slide, chapter 3 slide with you at the end of the day. if I forgot to share it, please remind me, because you need all these slides to prepare for your test. Remember that, please remind me, because sometimes, right, when I have to, when I'm doing other things, right, I tend to forget. I'm not young anymore. Just kidding. All right. So find specific energy. All right. Then using the specific energy equation, you get Y2. All right. You determine lah what state of flow. For example, in this case, right, this one is subcritical. It's supposed to be subcritical lah. So this would be in supercritical. All right. So I have another activity. You can try this out. Which is actually using this expression as well to find YC. Remember, you cannot use the simplification, this equation to find YC. Just be careful. This applies only for rectangular section. So if other than rectangular or including rectangular, you can actually, this applies for all sections. It doesn't matter, including rectangular, but this is only for rectangular. Okay. In this case, all right. So now, the same thing like how we solve for depth of uniform flow. For depth of critical flow, okay, you can also use graphical method. That means you are solving the expression, you are solving this expression. One is you use calculator to find, that means try and error to find YC. Else, okay, you need to plot out, okay, you need to plot out. It doesn't matter where your Y is. Probably you want to put Y here, or you can switch the axis. It doesn't matter. And another one would be A cubic over TC lah. All right, this one, okay. So you are going to have two tables basically, two columns, okay. One is Y, the other one is this section factor for critical flow lah basically, cubic TC. So you are going to have your plot. I don't know how it looks like, okay. Find this and then you can get your YC, because where is this value comes from? Comes from Q squared over G, okay. All right. Try this out, Try this out. If you have problem, let me know. I'm going to share this slide with you. All right. This is straightforward, Very straightforward. Okay. So I've plotted it. All right. I'm using x-axis for a cubic divided by TC. All right. Since Q squared over G give me 29.46. So I can find my YC. This is graphical method. If the question doesn't request you to use any method, you can straight away use calculator to find your YC or Y not. All right. All right. According to question lah. Okay.